In this video, we'll go over attributes and how to deal with them inside of Python SOPs. So for our first example, let's just go ahead and set the color attribute on this sphere to whatever the user's picked in this color parameter. So if we go to our type properties dialog and go to the code tab, let's just go ahead and delete this display message. It's annoying anyway. So the first thing that we're going to want to do is actually get whatever it is that the user's picked here. So if we go to parameters, we called it the color parameter. Go back to code. You can see that when we created this Python SOP, Houdini automatically added this line in here that says node equals who.pwd. So we'll just be using this variable to reference our node. So we want to get the value of this parameter, and if you recall, we can do that by saying color equals node.evalparm. So we can't actually just use evalparm here because we actually want to get all three in a list. So what we can do instead is say parm tuple color.eval. And that should return all three values. So let's go ahead and just print color and see that we've got the right things. And you can see that it's just a tuple that says 111. If we change this, you can see that it automatically updates as the parameter change causes the node to cook. So it seems to be working. So let's just set it to blue. Clear and close that. Alright, so let's get rid of the print statement, and let's take a look at how to use this. Alright, so what we're going to want to do is we're going to want to set the color attribute to whatever's stored in this variable. Now, there's a problem with this though, and that is that our color attribute doesn't already exist. We'll look at how to create it in a moment, but first let's look at how to set it. So if we just minimize this, let's add a point SOP. Clear and close. Let's go ahead and hit apply here. And then in this point SOP, let's change keep color to add color just so that we have a point attribute or a point color attribute. Alright, so if we come back to our Python SOP, let's look at how to set attributes. So the first thing that we're going to want to do is we're going to want to loop over all the points in our input geometry. So let's go ahead and do that. So for cur point in, and then this geometry object has a points function on it. And this points function will return all of the points in the geometry. So this will have us loop over all those points. So now we could say something like cur point dot set attrib value. And the way this function works is the first thing that it needs is a attribute name. So we can say cd. And the second thing it needs is the value that we're setting it to. So we could say color. So let's see what this does. If we hit apply. Alright, no errors. If we minimize, lo and behold, we have a blue sphere. Pretty easy. Now the interesting thing that happens is if we bypass this point SOP, our Python SOP actually errors. And you can see that it's complaining that no attribute with this name actually already exists. And that's because we bypassed the node that actually creates the color. So if we go back to our type properties dialog, we'll need to first check to see if the color already exists, and then we'll need to create it if it doesn't. So the way that we check to see if an attribute exists is we do if geo.find point attrib, and then we just give it a name, so in this case cd. So what this is going to return is actually a who.attrib. instance. Or it'll return none type if it can't find it. So in this case, we're just checking to see if the attribute exists. And if it doesn't, we want to create the attribute. Now notice this is only checking to see if it exists, so we actually want to say if not, geo.findPointAttrib. And that'll make sure that it doesn't exist if we're going to create it. So now if we say geo dot, what we'll want to do is say add attrib. And this allows us to add a new attribute to the geometry. Now the way this function works is you give it a type first. And what this type is, if you notice, this add attrib function is actually on the geo object. So we're not actually adding it to any points. So Houdini doesn't actually know if it's supposed to create a point attribute or perm attribute or whatever. So that's what this type argument is for. So the way that we tell it that is we do who.attrib type dot, and here's all the different types of attributes there are. In this case, we want to create a point attribute, so we'll just give it a point, and there it is. The second thing that it wants is the attribute name. So the name, we can give it CD. And now it wants this default values argument. So the way this works is the way that Houdini determines how many values this attribute contains. So whether it's a vector or a 2-float or a single float is with this default value parameter. So the attribute will contain as many values as you put in here. So if I did 0, 0, 0, it'll contain 3 values. If I did 0, 0, it'll contain 2 values. So we want it to contain 3 values, so we'll just add this in. Now the other issue with this, we'll see if we hit apply, the node will still error. If we look at this, it'll say no attribute with this name and type exists, even though we just created it here, so it gives. Well, the problem is that you'll notice that if we comment out these lines and hit apply, and get around the Houdini bug, you can see that it actually did create CD. The problem is that if we right click and go to extended information, and go to point attributes, notice that it created it as an integer attribute. And this parameter is returning a tuple of floats. We actually want it to be a float attribute, so why did it create it as an integer? Well, this is because of, again, this default value argument. We're giving it integers here, so it's creating an integer attribute. So the way that we can get around that is we just put 0.0 here to tell Python, hey, these are floats. So now if we uncomment these and get rid of this pass line, hit apply, no more error. We don't need that point SOP, and our sphere is blue. Okay, so what if we want to remove an attribute instead of just creating one? Suppose that we want to make sure that any other CD attribute that exists on the points is destroyed before we go in here. So say someone creates a CD attribute that's integer, we want to make sure that it gets destroyed so that we can replace it with our CD attribute. So the way that we would do that is we would actually grab this, the return value of this function, which is the who.attrib. So I'm just going to control C to copy, and we'll say CD attrib equals control V. So it's just finding that point attribute. So the CD attrib variable now contains a function called destroy. And this will delete that attribute. So now that we've destroyed this attribute, we know that it's not going to be there, so we don't need to do this check anymore. We can just delete this and then bring this back. So now it'll automatically destroy any attribute that already exists, and then it'll add it in. Now there is a slight flaw here, and that is that if this attribute doesn't already exist, then this is going to be set to none. So it'll be trying to call the destroy function on none type, which will break. So all we need to do is check to see if cd attrib already exists before we run this destroy. So now if we hit apply, it should work the same way that it did before. But if we do an attrib create here, and wire it in, and go to display it, we make cd, make it integer perhaps, and 3 size. So now if we go to our extended information and go to point attributes, you can see that it is an integer attribute, so this should break our node. But since we have that extra check in there, we can display this and it still works. And that's because it's destroying the attribute there. So now if we go to extended information on this guy and go to point attributes, you can see that it's a float. So it did work. Okay, so what if instead of just setting this attribute, what if we wanted to add this to the current color? So we wanted to say add 0.5 blue to whatever the current color is. Suddenly this doesn't quite work because we're destroying the attribute before we actually get a chance to add to it. So what we probably want to do is get the value of the attribute before we actually destroy it. The problem is that when we want to get the value of an attribute, we actually need to get it off of an individual point. Because if you think about it, if we just wanted to get the value of the attribute off of this guy's a global attribute. He has nothing to do with an actual point. You'll notice that we didn't get him off of a point. So the only way that this could give us our values is if it returned all of the attribute values. And in fact, there is a function that will do that. It'll put them all into a string. But that's probably not very efficient because then we have to parse the string and then add our values to that. So rather than doing that, what we can do is just remove this destroy code for now. And then we'll also need to comment out this line because it's going to be trying to add an attribute that already exists and it'll raise an error. So if we hit apply, no errors, and where we're at right now is it just colors the sphere blue as before. Okay, so the first thing we need to do is get the current color from the attribute. So we can do something like cur color equals, and then we want to get the color off of the point, off the current point. So we would do cur point. And then if we do use the attrib value function, this function will return whatever the value is of an attribute on the point it's called from. So if we do curPoint.attrib value, it'll look up the value of an attribute on that point. All it needs is the name of the attribute that we want to get, so we can say cd. And that will actually return a tuple containing all the values of the cd attribute. Now we can't just do color plus curColor, because this will append curColor to color, and we'll get actually 6 values. And then this setAttribValue function will think that we're trying to set a 6 value attribute. And if we hit apply, you can see that it errors and it starts complaining about the size. So that's why that's happening. So instead what we'll want to do is to add together each of the components of the colors. So the way that we're going to do that is to use the Python zip function. If you don't remember how that works, basically what it does is it sticks 2 lists together and allows us to loop over both of them. And as long as they're both the same size, we can get the same elements from both lists. So if we said something like for cur value new value in zip color, cur color color, these are going to be our 2 components that we need to add together. Now we need to store those in another list, so let's just go ahead and create an output color list. And then just do output color.append cur value plus new value. Alright, and then we just need to change the set attribute value to output color and hit apply. So we're adding 0.5 to red 0.5 and green 0.5. So if we minimize this, we'd expect to see a gray sphere, and that is indeed what we see. We could have 0.2 here, and it's very red. If we bring up the spreadsheet here, just to make sure it's doing the right thing, you can see that CD Y, in this case, is set to 0.7 and the other two are set to 0.5, so it seems to be working. Alright, so let's cover the fringe case where this breaks. So if we go to attribute create, and instead of a vector, we set this back to an integer. Our node errors as expected because CD is actually an integer now. So we'll need to check for that. So if we bring this back up, what exactly do you want to have happen if the attribute is the wrong type? Well, one thing that we'll notice is that this error is not very useful for most people. They're going to be like, no attribute with this name and type exists. I don't even know what that means. What attribute is it talking about? Is it the name? Is it the type? What's going on? And then they're going to have to try and guess at what this error actually means. So let's take a look at how to make Python SOPs raise useful errors. So the first thing that we'll want to do is check for this actual specific case so that we can return an error message that tells them exactly what's wrong. So in this case, our attribute is an integer. So how do we check to see if CD is an integer? Well, we'll need to find that attribute again. So if we say CD attrib equals geo.findPointAttrib CD. And the way this works is there's a function on who.attrib called dataType. So if we do CD attrib.dataType, this will return the data type, which is this here. So what we can do is just say if that equals. So what that data type is it's an enumeration that we can access from the Who module. So if we say who.attrib data.int, and now we're going to kick up our error. So the way that Python works is you'll notice that, or the way that Python SOPs work is you'll notice that when we middle mouse on this, it's actually telling us the traceback that we're getting inside of the Python module here. So that means that if we were to raise, say, who.operationFailed in here and hit apply, we would expect to just get operation failed. Now the cool thing about this is that if we give it an actual error message, so we raise who.operationFailed and then comma, and then we give it something saying like CD is an integer, it must be a float, and then hit apply, it'll actually print out that message. Now there is something that's kind of annoying about this, and that is that this traceback is being printed here. Now normally it's kind of a bad idea to hide errors, but in this case, your traceback, if instead of just being operation failed, say this error was coming from somewhere much deeper inside your code, this traceback could actually be really long, which could make it really hard for a user to get to this message and diagnose. So it might be a better idea in some cases to actually hide this traceback, and for that, Houdini has a function in the Who module. So basically what we need to do is instead of raising who.operationFailed, we can raise the special error, which is who.nodeError. Who.node error is specifically for Python stops. So if we hit apply, you'll notice that now that traceback is gone, and the actual error is very, very clear. CD is an integer, it must be a float. We change that, the error goes away, and the node works as we expect.